The fundamental theorem of algebra says if p of x is a polynomial of degree n greater than or equal to 1, then p of x equals 0 has exactly n roots, including multiple and complex roots. What this means is whatever the degree of a polynomial is, that's how many roots the polynomial has. So a polynomial that is degree 5 has 5 roots. If it's degree 7, it has 7 roots. And that includes both complex and real roots. So if we look at this first example, how many roots does each polynomial contain? Part A, we just need to find the degree of the polynomial. And this polynomial is degree 7, so this polynomial has 7 roots. That doesn't mean 7 real roots. It may have 7 real roots, or it might have some real roots and some imaginary roots, making a total of 7 roots. In g of x, first we need to figure out the degree. We could do that by adding up the multiplicities of each factor, or finding the leading term. If we found the leading term by multiplying the biggest term in each part, we would get 3x squared times x, and then the last factor would have an x squared, and if we multiplied those all together, we would get 3x to the 5th power for the leading term. Also, the multiplicities of the factors for g of x are 2, 1, and 2, and those also add up to 5. So that means this polynomial, which is degree 5, has 5 roots. Now, in this one, we can tell what those roots are. And at first glance, it appears like it only has 3 roots because we see 3x squared, so one of the roots is 0. And we see x minus 2, so one of the roots is positive 2. And then x plus 5 is a factor, so negative 5 would be a root. But 2 of those roots have multiplicity 2, so we think of those as double roots. So if we listed the ones with multiplicity 2 twice, we would have 0 twice, 2 only once, and negative 5 twice. So this polynomial actually has 5 real roots. And let's add one additional example. Let's say we have some polynomial h of x equals x squared minus 9 times x squared plus 16. And I can factor that a little more. X squared minus 9 is the difference of squares, so I could rewrite that as x minus 3, x plus 3. But I can't factor x squared plus 16 because you can't factor the sum of squares. Okay, so for my real roots, we get positive 3 and negative 3. But if I set x squared plus 16 equal to 0 and solve, we get x squared equals negative 16. And I square root both sides, and I put a plus or minus, and we get x equals plus or minus 4i. So in this problem, we have 2 real roots and 2 imaginary roots, or complex roots. And those are positive 4i and negative 4i. So this polynomial would cross the x-axis twice at positive 3 and negative 3, and then it has additionally 2 imaginary roots, which is not a place that it touches the x-axis. But the degree of this polynomial is 4, and when you add up the real roots and the imaginary roots, you get a total of 4 roots.